What's up guys, Jacob from FuelTech USA, and today we're going to go over the advanced map options section in FTManager. So before we get into it on the computer, the advanced map options section, that's something you usually wouldn't go into. Normally if you call the tech team, that's going to be something we help you out with. If you've got a weird crank trigger, we need to adjust voltage levels, or if you wired the car from scratch, you've got an injector output mixed up, this is going to be where you can go and turn on the options and give you a little more configurability than the average user needs.
Alright guys, so hopping on the computer, we have one of our sample start maps open. We're going to go down to engine settings, advanced map options. There's a lot of stuff here. So starting out, we're going to do fuel maps and ignition maps. These are both set for table. If you make a tune from scratch, it's going to start you out as table. That just means it's a 3D. It's got 2 axes like this. Something super basic in here. Fuel table. The line is more a legacy thing, something that was left over. The one that I see this most commonly used on would be like, I've seen it some carburetor guys, sportsman guys that don't really care about a ton of resolution, especially if you got like a distributor or just all motor car, you're just going to run just a locked out timing number all the time. Warning, yes, it's going to convert. Now, that's your timing table. And you have, instead of it being on 2 axes, there's a separate table for map compensation. So if this is just a basic distributor car, you're going to run 34 degrees all the time. Boom, put that in there, you got 34 degrees all the time. Map compensation, this is just saying if you want to manually take out X amount of timing with boost, you can do it this way. Fuel table is the same thing. It's going to give you a 2D line, something real basic. So now we have just a basic straight across, just 1 axis, and this is only based on vacuum or boost, what you want for fuel. Then there is another option here for RPM compensation, so you're going to have your flat table there for the boost, and then what do you want to do with RPM. And there's also a TPS compensation you can use if that's something you want to do. Most guys are going to stay on the 3D table. For me, it's way simpler. It's just what you're used to, but the table is, my opinion, the way simpler way to go about this. So the next one, this is more commonly, I see guys turn this on, fuel injection pins assignment mode, ignition pins assignment mode. So right now it's set for automatic. So what that's going to do is if we go to our outputs, you can see we have blue 1 through 8 and gray 1 through 8 are assigned for coils. Let's say you wired this thing from scratch and you accidentally put the number 3 injector on the number 2 blue. And you can't change it like this. This is going to allow you to do that. Advanced map options, put fuel injection pins on manual, ignition pins on manual, hit confirm. Come back to outputs. Now these are unlocked and you can move stuff around if you need to. So we'll say you wired it from scratch, you mix something up. That's an easy way to fix it. If you buy a Chevy harness and you put it on your Ford, you can plug it in Chevy firing order, basically 1357 on the 5678 side, and then you can reassign here and get your stuff in order. The ECU does not care what order this stuff in. It doesn't have a preference. Like injector 2 can be on blue 11. The ECU doesn't care. Something else, like let's say you got a Viper and you got 10 coils. You can actually use a yellow to drive a coil. But just a small disclaimer, if you've got all your coils on grays and you've got a couple on yellows, there may be some very, very slight timing variance on your yellows. I'm talking about like 0.2, 0.3 of a degree. It's going to be hard to measure, but I just wanted to throw that out there for you guys. So before we change anything, I'm going to go and put in something I commonly see this changed on. Let's say we have a Harley, and it's a 45-degree V. How do we make that thing fire right? We're going to go to Advanced Map Options, turn on Custom on both of these. And the correct way to set up a Harley would be 0 and 315 for cylinder number 2. You can do that on the ignition and the fuel, just so everything's at the right time. This thing will run with the fuel wrong, but it will not run with the ignition wrong. This one, O2 closed loop default. I would not recommend turning this on. I'm just going to turn it on and show you guys. The closed loop works really good. The closed loop is killer. Just how it is out of the box, I've used it on everything. But if we go to custom, the major change is it just gives you this advanced options. You can play with the control loop, the PID right here, and loop time. This is kind of a refresh rate. I don't even have any good numbers to give you for this because the default works so good. You should probably not ever turn this on. Yep, back to default. Let's go to the RPM settings right now and see what kind of options we got. This is just super basic VR, rising edge, 12-1. Same with the cam sync, Hall, falling edge, 90 degrees, super basic stuff. If we turn on these advanced options here, now we get this. So with the advanced setup, sensor conditioning mode, you can do manual levels or automatic detection levels. I would not recommend automatic detection levels. If you're really struggling to maybe get something to show RPM, you could try automatic detection levels, but it's not very reliable compared to manual fixed levels. Internal bias reference. So I will show you on the wiring harness diagram. This is a 550. So we have a red wire and a white wire for RPM signal. The red wire is your main one, and this is going to control the pull-up on that red wire. So if you were to unplug it and probe it, and this is what your settings are, you're going to have around 2.5 volts on that wire. If you put 1 and you probe it, you're going to have around 1 volt on that wire. This can kind of help with making the signal a little stronger, a little weaker, depending what you're working on. So magnetic trigger levels, 0 to 2000 RPM and over 2000 RPM, you see we have 2 separate boxes. This is more the 0 to 2000. This is more just cranking the engine, idling, making RPM work there. And then over 2000 RPM is going to be always a higher number. So let's say a VR sensor, the signal gets stronger with RPM. So usually this is a really low number because we have to make this thing read just on the starter, which if you got a good starter, you're turning 200 RPM, 250, that would be pretty stout starter battery setup. We need that engine speed to give us at least this strong of a signal, and you can check this on the tools and oscilloscope mode when you're plugged into your ECU. But this is the threshold that the ECU is going to count that wave as a tooth. So we need to be above 0.16 volts. If you got something with a super weak signal for whatever reason and you can't really do anything about it, you can lower this. But just something to keep in mind, if you get really low down here, like 0.01, 0.02, something like that, just a very slight variance in wiring, or you could turn the switch on, or when you hit the starter, if there's a little bit of noise in that signal, then the ECU is going to think it has RPM. It's going to fire a coil. It's going to fire injectors. So keep that in mind. I usually only see this with some specific trigger wheels that we have to adjust anything here, or a lot of modern VR stuff like jet ski, side-by-side, stuff like that. Usually the signal is really strong and it'll make it unstable at these lower levels, and you may have to raise this way up to make this thing keep RPM. Cam sync, same thing. Internal bias reference and the magnetic trigger levels, same exact function as the RPM signal one. But if we have cam sync for synchronization only enabled, this is really all that matters. You could put whatever you want over here. It is not going to care, because all this does is we're going to look at it for 10 revolutions, and then we don't even care about the cam sync after that. We know the firing order. We know everything's in the right order. Cam sync could fall off the motor. You could go unplug it, whatever. It's still going to work. Internal Datalogger settings. This is one, if you seriously race a car a lot, I would recommend turning it on. Roll up here to the Datalogger, and this is all the same. The sampling rate is just an overall change for everything. But now we have individual channel options. So if we're RPM, we're going to do 200 hertz. Something like battery voltage, it shouldn't change that fast. You could do 5 hertz. Fuel injection phase angle, a lot of guys just run a flat number in there. That could be 5 hertz, it could be 1 hertz, it doesn't really matter. So the idea here is we're going to turn up the sampling rate on the channels we really care about and turn it down on stuff that doesn't even move fast or stuff we don't care about. This kind of makes your log more efficient. It doesn't take up as much room because we're not logging battery voltage at 200 hertz, 200 samples a second. It's not going to move that fast. So that keeps your logs a little shorter and compacted down. You can run a longer log with higher sampling rates on the channels that you just like really care about. Idle speed control, this one is not commonly turned on, but just to show you guys what you can do here. This is one of actually the more complex controls you can turn on. It's the whole PID loop. There's a timing compensation, target approach rate, deadband, approach RPM. Just to not kill you guys on explaining all of it, if we open the help tab, hit that little arrow right there, and go all the way to the bottom, it's really detailed and explains everything you need to know about this. Even shows what the default numbers are. It's pretty useful if that's something you want to go after, but most of the time you don't have to turn this on. Just idle by timing or your idle position stuff over here works fine. Active traction control. I'm going to show you guys what it looks like first before we do anything. So mainly you're going to play with this reaction level to decide how aggressive this control is going to be for the active traction control, either doing the ignition retard or the ignition cut. If we turn on the advanced options, it just gives us a PID that you can play with. I don't recommend this one because that overall change is so easy. So now you see reaction levels grayed out. This is now your reaction level stuff. This would take a ton of testing to get this dialed in, as easy as reaction level and just go up or down a couple levels and get it smooth. I don't see this turned on very often. So now we're going to do the boost control stuff. So wastegate boost pressure control, wastegate boost pressure control 2, they're the same thing. It's just if you have two boost controllers, a compound turbo setup, or I don't know, if you're trying to run shocks through a boost controller or something like that, you may end up using boost controller number 2. I'm just going to work on number 1 right now. So to show you what it looks like before we do anything, most of your PID adjustment will be done through the control gain or CO2 bottle pressure. This also changes stuff in the background. This does to valve model. It's important to select the right thing you have here because the default PID works on most applications. Then it's just target overall trim. If you want to add 2 pounds to everything, you can do it here. And then this is your time-based table. If we go to advanced map options, we're going to turn on custom for that. Hit confirm. Come back up here to Wastegate boost control. You'll see there's already another table here that wasn't here before. This can be really helpful if you're using injectors for boost control and you have a voltage and a pressure and a dead time table. You can stick it all in here and it's going to make it work way smoother. If you don't have injectors, you have our boost controller like the dual block valve, or you got Mac valves or something like that. That may just take some dialing in, seeing what reacts better on the dyno or track, wherever you're running this thing. And now you see our control gain number is just gone. And now we have a PID to play with over here. So this is just proportional integral derivative gain, super nerdy stuff. If you know what to do tuning PIDs, you're going to be all right over here. PWM frequencies, how fast we're trying to pulse these solenoids, and this is control gain. We do still have a kind of a manual number here. Most guys, you're not going to be out of the 17 to 22 range either here or on the default settings. Again, this is something not commonly turned on, but if you've got something with really tiny gates, like I've had to do this on snowmobiles or motorcycles, stuff like that, then this may be something you have to play with. But if you call into tech support and you're having boost control problems, something's unstable, something's wavy, something's bouncy, and you have this advanced turned on, the first thing we're going to do is put you back to the default and run it like that, because the default works on most applications. Boost control number 2, it's everything the same, it's just on the second boost controller. Electronic wastegate control, I'm going to show you the default way it's set up. So nothing super complex. So here we have control response level. This is basically just changing the PID in the background, and this is how aggressive you want the control to be. This is overall trim. You want to add 2 pounds everywhere, do it here. Time-based after 2-step, put it here. We have a base opening table. This is, think of it like a fuel map. This is like, you're going to go ahead and pre-plot like, okay, 6,000 RPM, 11 pounds, this thing's going to be 30% open. The closer you get this, the less the PID has to work. So if you're really fighting something, I would worry more on dialing in this base opening table than going and turning on advanced options and giving you way more stuff to adjust and worry about and wonder if you're even doing the right thing. Just to show you guys the advanced settings for the E-gate, we're going to go to turn that on. Go back up here. Now we have, see that box is gone. And there's a ton of other options here. If you've got 2 E-gates on the car and one seems to act different than the other, maybe it's plumbing, maybe it's the gate, something like that, you can play with the PIDs separately per gate right here. It gives you a deadband percentage you can play with. Disable position control, protection, not recommended. This is a good way to burn up your E-gates, so I would leave that off. You have a map control as well, distance and percentage of target map. Integral anti-wind-up setting here you can play with. This is complex stuff, guys. So if you're not a PID tuner, this is something you should probably stay out of, or you should get some help with before you get in here and moving stuff around. We have our same basic couple tables here, and then we have an overall P table. So this is the P and the PID. So it can change depending on the average duty cycle of the gate and how far away from the target we're at. The P, the I, and the D. You can adjust all of them, and it's the PID overall is moving. This again, complex stuff. If you guys are not familiar with PID tuning, I would probably keep this stuff turned off.
All right, guys, so that covers the advanced map options, when you would use it, why you would use it. Just because it's advanced, you don't have to turn it on, but this is going to help you guys out if it's something you need to do. If you guys still need help with something, of course, reach out to the tech team, like, share, subscribe, all that good stuff, and we will see you guys next Tuesday.